My name is Hanan Farhat. I'm a materials and metallurgical engineer, and this is what I did as an undergraduate degree, and I did my master's and PhD in Canada at the University of Saskatchewan. And my master's was focused on welding metallurgy, and my PhD was in corrosion. I've worked with the oil and gas industry for about almost 40 years now, believe it or not. And well, no, almost 30 years, sorry, almost 30 years. But I left the oil and gas industry and shifted to work in research in the past 12 years. But my research was industry demand driven, which means that every research project I worked in had an industrial partner, an industrial problem to solve. And so I always consider myself, connected to the industry. And I'm currently going back to the industry again, seeing how things are changing with the new technology and digitalization and everything. It's good to be back to find out what's happening around us. With research, I created a corrosion center in Qatar. I'm now based in Qatar. I'm Canadian, but I've been working overseas for a long time. And the corrosion center was focusing mainly in oil and gas research. Unfortunately, due organization restructuring, we were part of a university. The corrosion center was decided to be gone. And I think it's mainly for the lack of understanding the importance of corrosion. And I think Zoe spoke about the impact of corrosion and how much it costs. But just to give you an impression about it, in the Middle East, where I am now, it's about 5% of the country's GDP is spent on corrosion. So it's significantly high. So in my presentation, what I decided to do is to talk to you about some of the ethical challenges, considering the topic of this, that I faced in my work and how I dealt with them. And if you don't mind, I might be in some of the slides, I might pause and ask you questions so I get some interaction, either virtually or from the Canadian audience, if that's okay with you, Yolanda and Naomi. Okay. So for corrosion engineering jobs, the ones that I held and the ones that you're mostly going to see in the industry, you could either be a corrosion engineer, you could be an inspection engineer, or you could be like what they call the reliability engineer or asset integrity management engineer, which the last one comes usually in when you have a bit of experience, you end up in the asset integrity management part. I did not put research here because I believe that research combine the three together. So if you're working as a corrosion researcher, you'll be working with the three main jobs. And I'm going to give you now a few case studies that I faced when I was performing all these jobs and discussing, what you face as a corrosion engineer or an inspection engineer or asset integrity engineer as an ethical challenge, and how do you meet it. So every engineering profession has ethical challenges, every one of them. And being part of the Professional Engineering Association of Professional Engineers in Canada, its ethical responsibility is fundamental, and it's important that you keep your ethics. And if you're part of the association, and if you're not part, I encourage you to join as an engineer in training. And one of the requirements annually is that you need to take ethical course every year. And I can tell you that it is important because it's a reminder of your duty. It's a reminder that if you want to be a professional engineer, you have to keep this responsibility. The society is trusting you. People at work are trusting you. And we as engineers, we want to keep the respect and the trust that we have. And so you will face a lot of challenges in your work and in your daily life, but at work specifically. And so in some cases, I have to say, I had to fight for my ethics, but it's important to stick to your ground. And the first case study I will talk about is corrosion inhibitors. So if you're working as a corrosion engineer, and if you are in charge of corrosion management, one of the things that we do, we add corrosion inhibitors to the streams, to the pipelines, to equipment. And these corrosion inhibitors are chemicals. And most of these chemicals are harmful to the environment. And so it's very, very important to use the right dose of corrosion inhibitor, because adding more corrosion inhibitor, all the research studies, all the facts show that it's useless. It's not going to make things better. So if your pipeline, let's say, that is supposedly protected and has issues with corrosion, the solution is not to add more corrosion inhibitor and increase your dose, because 80% of the times, it's not the right solution. The solution is to take some samples, send them to a lab, test them, check the performance. You might need to use a different inhibitor, or you might need to reduce your inhibitor, believe it or not, or you might to need to adjust your dose. So that's very, very important part. Also, having more corrosion inhibitors is costly. So it's not only affecting the environment, but it's also costing the company that you're working at a lot of money. One important thing to do when you're using corrosion inhibitor is to monitor the performance. And how would you do that? Is by taking regular samples and checking. So how do we do this? So you have, let's say, we'll talk about pipeline, which is a common way of using corrosion inhibitor. You put your corrosion inhibitor in the pipeline stream, and this corrosion inhibitor is expected as a chemical to stick to the metal surface and protect it, and doesn't get the water to react with the metal surface. That's the idea of corrosion inhibitors. Now, when the companies select corrosion inhibitors, they see their parameters. They say, okay, this is our pH, this is our water composition, this is the flow, all these parameters. And then they take these parameters and then they start doing testing in a lab to decide what corrosion inhibitor dose they need, and then what type of corrosion inhibitor would work for them. So they will test multiple kinds, and then they select the one. Now, pipelines are actually dynamic, they're not static. So as the oil and gas comes from the wells, the composition of the water change, the pH change, the flow change. There are a lot of changes. So what worked today may not work 6 months from now. So in order to make sure that everything is okay, you have to take samples regularly, check the corrosion rate. So take samples from the corrosion inhibitor, do electrochemical testing using a material, the same material of the pipeline, and measure the corrosion rate. And then 3 months or 4 months later, 6 months later, depending on how critical is your asset, you do another test and you check your corrosion rate. And if you see that it is increasing, then your corrosion inhibitor is not working and you have to act. This process is very costly, because the regular you do it, you have to take samples from different location if it's a long pipeline, but it is the safest way. So you as a corrosion engineer and and a company doing a corrosion management have to emphasize the need for corrosion inhibitor monitoring. The other issue we face is the disposal of these chemicals. And so it depends on where you are, but in some locations, these chemicals end up in the sea and end up in, affecting marine environment. So you, as a corrosion engineer, when you are involved in the planning of corrosion management, you also should emphasize that you should be also included in the disposal of these chemicals and knowing where they are going and what's going to happen. And there are few options, very, very few options of environmentally friendly corrosion inhibitors that started to come to the surface. And I think it's important to be innovative. It's important to try them. And sometimes it's difficult to try something new. And sometimes you're afraid that it may fail, and then it would show that you failed at your job. But I always believed that sometimes it's possible, important also to do what is needed to be done, and it wouldn't hurt to try something new, even though if it doesn't work, at least you tried. And so this is my advice regarding corrosion inhibitors and the challenges that we face as corrosion engineers dealing with these chemicals that are important for us. The second case study I'm going to talk about is an inspection. So I worked as an inspection engineer, and part of my job was conducting what they call risk-based inspection, RBI. And if you, finish your study and you look at jobs in the industry, you will see a lot of RBI jobs that are available. It's a very hot topic. And what risk-based inspection does is that they do a corrosion study. It's conducted by looking at the whole plant and then divided the plant into corrosion loops. So you look at the materials of this equipment in the plant and their parameters. And based on the material and the parameters, you could predict what type of corrosions you may find. And then you divide these corrosion types into loops. So you will have, equipment A in one side, equipment B over there. Both are part of the same corrosion loop. And you could do corrosion study to determine you predict the corrosion rate. And there are lots of softwares nowadays that help you doing that. When I started this job, we used to do this manually, but now it's all automated. And then it would divide your plant to a matrix, and this matrix has a relationship between probability of failure and the consequence of failure. The higher the probability of the failure and the higher the consequence of this failure on people's safety, on the environment, on the production, losing product, the higher both of those would put the equipment in the high risk category. And based on the risk category, you can plan inspection. So you could say equipment A has high probability of failure, high consequence of its failure. So we need to inspect it once every year. We cannot wait 3 or 5 years to inspect it. Now, just to give you a perspective of inspection, if you want to inspect equipment, this means that you need to shut it down. This means that you're going to stop production in that equipment. That costs a lot of money. And you need sometimes to empty that equipment to go inside and check if it has corrosion or not. So that's also cost, efforts, and time. And so inspection is a bit costly process, but it's important. External inspection is easy. You can just walk by and find out, and now they use drones to check if there is any problem. Internal inspection, which is the most difficult part because internal corrosion is the the thing that is causing most of the failures, that one is costly. So you as an inspection engineer, if you become an inspection engineer, have an obligation to say that, no, we need to stop and we need to inspect. And I had faced a lot of challenges on this. And so we could sometimes do some testing when the equipment is up and running. We could use some ultrasonic testing methods, or we could use corrosion coupons to determine the status of the equipment to see if it's okay or if it's failing. And so if we find an indication that we have high corrosion rate, or if we find an indication that we have cracking, then we go and say, stop everything, we need to inspect before it propagates, and then it causes failure, which could harm people, which could lead to pollution, which could stop the whole plant, and it cost us a lot of money. I faced cases when I were in that situation, when somebody comes to you and challenge you and say, they challenge first your qualification. What's your qualification? What's your experience? And if you're a woman, the challenge is more even because like they come and say, how long you've been working at the plant? Have you ever inspected something like this? So I face those challenges a lot, not only one time, many, many times. And people sometimes treat you like an enemy when you come to them and say this, because they have everything going smooth, and you come and say, hey, this equipment is started to corrode bad, and I think there is a crack going on there. It might fail. So you interrupted their budget, their schedule, their timelines, everything. You ruined everything for them. And some people don't want to hear it. And they try to brush you off. They say, no, I think it's fine. It's not bad, not bad. So I hear this word a lot. It's not bad. It's okay. We have this equipment running for a long time. We never had a problem. I've been working in this plant for 30 years. We never had issues for this. They just brush you off. Now, this is where you need to think about your ethical obligations, and you need to report it. You have a duty to report. And in many, many incidents, I had to report things to the upper management when maybe my immediate manager did not want to act. And it's tough. I can see it, but you create enemies. Your immediate supervisor will hate you and make your life miserable after that. And so there is a lot of consequences. I had to leave one job because I had to report things to the upper management, and I'm glad I did because I saved people's lives and I saved the plant. But at the same time, I suffered from that and I had to resign because of the bad treatment that I had from my immediate supervisor, who was the one who wasn't taking action, you know. And so this is where you have to decide, let it go, keep it going like what it is, and then maybe something happen and you decide, would you want to live with that? Would you feel good about yourself? Or act and do what's the right thing, even though it may cost you your job. And I never regretted anything I've done because I felt that I always have done the right thing. And I've always felt satisfied. I can sleep without feeling guilty. And I don't need to, you know, be part of something that would hurt people. So that's what I want to, you know, emphasize for you. I would say that inspection engineering job was the most stressful job I ever had. And all the inspection engineers I met with, you know, in my life and in my career, or inspectors, because there's the technicians that do the NDT and do the inspector, all of them, they said that, you know, they are always feeling that something wrong might happen and they would be held accountable because you are at the end held accountable because you're responsible on this. So if a plant fails and you did the inspection report and you did not raise concerns when there are evidence, it comes later. So that's also, this is why this job, I've seen, at least from my career, it's one of the jobs where people tend to retire early because of the stress associated with it. And so if you find results that are not positive, not pleasing anyone, it's okay. Do what you think that you're supposed to do. And please don't listen when people say it's not bad, it's going to survive. No. Use your engineering judgment and think about it and report it. Even if they don't think it's bad, you need to have a record of it. That's my advice in case 2. Case 3 was an interesting case. So when I started working in research, I started doing a little bit similar to what Zoe doing. So I was doing a lot of consultancy. I was doing, you know, with the corrosion center, we were doing a lot of failure analysis. The center's budget was mainly came from the industry. So we were pretty much, you know, depending on them to get things done. And we often get a lot of cases of failure analysis. And one of the cases, which is the one that you see the image here, I don't know if I can find the laser pointer, but this is the, I'm not too familiar with Zoom, unfortunately, but I think, oh, only I can annotate. I don't know if I can get a laser pointer.
On the bottom, Noémie.
I don't see anything here. Anyways, can you see my cursor when I'm just pointing? Yeah, okay, so these holes here, this is a part of a LNG plant turbine. So natural gas turbine. And these turbines are biggest part of the whole plant. And what happened to this turbine, it failed. And it's actually, I don't know if you see this image, but these are the pieces that are broke of this turbine. It's a huge turbine, and this is part of it. And they brought it to us to do a root cause failure analysis. And when I looked at it, you know, we usually plan what type of tests to do. So we were, you know, working in labs similar to what you do at the university. So we will do macrography. So we look at the macrostructure and imaging from outside. We will do metallography. We look at the microstructure, cut samples, and see what happened to the material. We would do XRD, for example, in some areas, like there is some powder that was collected from there. So we can do XRD on that. We could do XRF also on the samples, XSPS, SCM, and EDS. So there are lots of, you know, tests that you could do. So we planned for this specific failure, we planned 6 tests. We did the first test that was macrography, and then in these holes, if you see these type of, you know, needle sharp parts, we found that the holes were blocked with a powder. So we just pushed the powder out and we took the powder in XRD and we analyzed the powder. And we found out that this powder came actually from a sealing that they use for these pipes, for these sorry, not pipes, for these turbines. And we found out that what happened is that when the turbine was refurbished, and they sealed it. But what they did with this sealing material, they did not clean the holes after they sealed it. So the powder that they sprayed went all over the holes and covered the holes. And it's a turbine that gets heated. The holes are made for ventilation. So when they were covered, it got overheated. And as it overheated, it started to become weak. And then it's a turbine that is rotating. The blades started to break, and that's what caused the failure. And so from test 2, we found out what happened. Now, shall we continue, if you were on our side, the testing to confirm our findings are okay? Shall we look at the microstructure, look at these holes, see what's inside? So I'm going to pause here and see if we can get some answers. Would you continue or would you stop here?
Maybe we can do for the people in the audience, can you raise your hand if you wish to continue?
Okay.
I will.
We got some few messages saying that they would continue.
And so, yeah, so I would say there are a few people that will continue.
Okay.
And in the Canadian part,
if you would like to continue, you can raise your hand.
So in the Canadian part, apparently they don't want to continue. Okay. There is no reason.
Okay, so we have virtually, we want to continue. In person, we don't want to continue. Okay, it's good to know. Okay, let's go. So
it's cultural.
The study was planned to cost $20,000 if we do the 6 tests. If we only conducted the 2 tests, it will cost $5,000. And so now here is where your ethical obligation comes in. We needed the money. It will help. It pays the salaries of all the postdocs that we have. They're all getting paid from this, from the funding we get from the industry. So this is where you say, okay, I know the answer after the second test. Why would I charge the company $15,000 for tests that actually are useless? Because they know now what caused the problem. They can solve it. It's done. They don't need to continue. And so this is where I feel that your ethical obligation comes in, because there is the money factor. So the people that said we will continue, yes, from research point of view, we actually continued afterwards for us, just for our knowledge later, when we had time, and we shared it with the company. But from a financial point of view, the customer, the company, should not pay the 15,000 because we knew what happened. So we actually stopped, did the report, gave it to the company, because also the plant is stopped. They're waiting for us. And so we gave them the answers, and we got paid 5,000 instead of 20,000. And this is where you actually have to make the tough decision. It's not money. It's the right thing to do. And you know what happened? The company came to us and gave us, at the same year, we had 7 other failure analysis from them. Because I think what we did is that we showed them the quality of our work and our ethics. So they started to trust us more, that they had all their failures that happened were directed to us. They did not send their failures to anyone else. So always, when you follow the right way and you do what your ethics ask you to do, it may not look positive at the beginning, but in the long run, it's very positive. So this is case number 3. Case number 4, being a material engineer, I'm involved a lot in material selection. And this is a very challenging thing to do because, I select a lot of materials. So I work with metallic alloys, I work with ceramics, I work with polymeric materials like, plastic pipes or reinforced glass. And then I work with also selection of coating. And we always focus on, compromising between 2, having a very good quality material that lasts long, but also the cost should be good. So you have to think about it, okay, if stainless steel will work, I don't want to go for nickel alloys because they are more expensive. But if stainless steel will not work, I have to pay more and go for nickel alloys because they would last long. So this have to be made when you are looking at material selection. Now, one factor I look at always is that how critical is this equipment? Is it high pressure equipment? If it fails, would it hurt people, or would it cause a explosion or big failure or affect the environment? That's also affect our use of material. From my experience with companies, I find that the common practice is to try to default to the cheapest material. So we use a lot of carbon steels, but you could use a carbon steel, but also you could, most of the all the pipelines, most of the big pipelines are carbon steels, but you could clad them with an expensive material. So it's not going to be very expensive pipeline, but it's going to be safer. So you could find some compromise, some solutions that enable you to use a cheap material, but also provide protection. So we do a lot of carbon steel pipelines that are cladded with nickel alloys. So the internal of the pipeline is protected from corrosion. And I think this is a good way to support. Now, I find in some, areas where countries like in Africa, where the environmental regulations are relaxed, I find that the companies tend to go for the cheapest material. And when I'm involved in this, and when you get in the future being involved in this, you have to think about what is the right thing to do. Yes, nobody's monitoring there, but you as an engineer have ethical obligation to select the right material that would not fail and would not affect the environment in this country. So that's another thing that you would face when it comes to material selection, and you have to be careful on what to do. This is the last case study I'm going to present today. So it's about reporting. So I've seen this a lot. So you will go work, you do corrosion study, or you do fitness for service evaluation, or you do root cause failure analysis report. And when you finish, they come to you and they say, oh, some of these findings are really, really going to disturb people. Can you remove them? I've seen that a lot, and I faced that a lot. So what would you do in this case? And I'm opening the floor now also to discussion for this. Anyone who has any comments, either from again, virtually or, oops.
Those tricky results. I hope not.
It's hard to hear. I cannot hear you, Yolanda.
Oh, yeah. Yeah, just so how many would remove it? Nobody's. No, here it's. We have this discussion all the time because we have also industry projects. So we have. I have a lot of discussions with the students when they come to me. Oh, I got bad results for the industry partner.
Yes.
So but actually my experience is that a lot of industry wants to see bad result as well because they want to know, but they might not want to publish it, and that is also an ethical issue.
Yeah.
Yeah.
And that's very important that you brought this, Yolanda, because we, being in research, you always want to publish. And that's one thing I struggled with because I don't have many publications because all my work is with the industry. And so you can either pick that you have an impact, a research impact, which means an impact on the industry, or you would have a nice academic profile where you have more publications. And in my case, I picked the industrial impact because the work that I do, I cannot publish the results because of the confidentiality, but we learn from this research that we do, and we develop test methodology, and later we could use different parameters, different material, and publish papers, which what we have done at the Corrosion Center, that we did never publish the work for industrial partners, but we tried to use it to get us other areas. But with changing report, I, in some incidents, change things in reports. And I will tell you how I did it. And again, it's, it's very, very tricky. So I got 2 cases where I was told that if you give this report to the management, this and this person will be fired. Because the report, for example, shows that the cathodic protection did not work. And the upper management doesn't understand that cathodic protection may not work in some cases. And so they would think that the person who's responsible for the cathodic protection was not doing a good job. And so I had to spend time rewriting that part. I did not change the finding, but I rewrote the part so that when the management that is not technically, familiar with the topic and doesn't understand it would understand what I meant. So this was a case of a tank, a crude oil tank that had cathodic protection underneath it in the bottom, but the bottom plate of the tank was failing from corrosion because it wasn't protected. And the reason why it was not protected because the cathodic protection was not working properly. Because where we are in Qatar, it's all sand, and the sand is very soft and it has a lot of holes in it. And so the cathodic protection was not transporting very well. And writing the report, I said cathodic protection did not work to protect the tank, period. And then I was told, this person is going to be fired because they think he's not doing a good job, where he is actually doing a good job. And I can see that. I saw all the work that he's been doing. So I had to explain this part, that the job is done and it's giving a recording from the edges of the tank, but the middle of the tank, we're not getting any data. And this is why we're not getting any protection. And this is why we have the failure in the bottom of the tank.
So you save the asset and the person.
Yes. So in cases like this, again, ethic is very interesting topic. If you want to keep your ethic, you keep it, but you also you cannot be firm in things without looking around you. So you have to look around you. You don't compromise your ethic, but at the same time, you have to think about what is around it and what's the implication of what I'm doing. And I have to be very careful at every word I put in these reports to state clearly what went wrong and how it went wrong without impacting people who were doing a good job, and there were issues that are not in their hands and nothing for them to do. So that's the advice I would give you in